is our slip fit tolerance. And what I mean by that is when I go to put two parts together, when I go to slide them together, what tolerance or what gap do I need to put in between the parts to make them so they fit together nicely? So it doesn't matter what material it is, everything has like a shrink rate to it, and the amount of shrink after it solidifies or after it cools. So for PLA, ABS, PETG, all of them, everybody has their own shrink factor or their own shrink rate. So what I want to do today is I want to try out some PLA, and I have some Hatchbox blue PLA I think we're going to try, and it probably wouldn't hurt. We'll try out also some Hatchbox green, and I have a couple other different colors from some different manufacturers, so we'll give those a shot. So what I did for this test is I created a little die. This is just a little U-shaped die, and what I'm going to do is I made some square pieces. So for example, this one, and this is my 0.0 millimeter part. So we're just going to take it and slide it right into the die. So 0.0, there's no gap. So right around the perimeter of the part, there's zero gap. So it theoretically, in the real perfect design world, that is the most perfect fit you could ever get. It's zero. So what I did was I just kind of stepped it up, just a little bit of gap all the way up to 1 millimeter. So I started with 0, and then did a 0.3, there it is, 0.3 millimeter gap, and then did a 0.5 millimeter gap, 0.7 millimeter gap, and then a 1 millimeter gap. So 1 millimeter, I assume 1 millimeter, it won't even touch. Like, it shouldn't. 1 millimeter is pretty far. But who knows? I could be surprised. You know, I think depending on the material thickness and the volume of the part, that maybe the more volume that the part has, it might the shrink rate might be a little bit more based on the volume. I think I might be wrong, but if you happen to know that answer, if you're a chemical engineer, for example, or whoever, just comment below and let me know, because I'm curious, and this kind of what I'm working out with this test also. So okay, all right, so the very next step is to take these parts. Let's see, there's plus the die, 1 2 3 4 5 6 parts. So let's get these 6 parts thrown into a slicer, get them sliced out into G-code, and then drop that G-code into the 3D printer and get them all printed out. And then, okay, so now we are in Slicer, and so what I want to do is add our parts. So come in here, grab our parts, and open. So what Slicer will do is grab all the parts and throw them on the build plate and try to put them on there in a decent way. So what we want to do is bring them a little bit closer together. It would definitely help decrease our print time, so that way the nozzle head doesn't have to move so far. There we go. Bring all of our parts together. Little simple test. I mean, I'm pretty sure there's a million variables, but I think for what we did, kind of starts to stick that toe in the water and kind of understand how the materials react, how they shrink, and how they fit. I think understanding your fit will help you design your parts in the future. So that way you do little experiments like this and then print them out. So, you know, parts take hours to print. So if you can do little experiments like this, you can kind of know ahead of time what to expect on the far end. So I think the takeaway from this one is that 1 millimeter is like a mile. It's a huge gap. So we could throw that out the window, for at least for this little project. And then the 0mm, I think if I wanted something that slid together and stayed there, but it wasn't enough, wasn't such a tight fit, like an interference fit where it's going to deflect the part, 0 seems to fit pretty darn good. But I think for me, I think I got lucky. I think the 0.3 millimeter piece, if I were to design a part like a hinge or a box with a lid, I think that the 0.3 millimeter is going to be my little magic tolerance. So I'm going to just stick that in the memory bank whenever I'm designing something in Fusion 360. I need to keep that in mind, that if it's a hinge or something that needs to, gently fit together, 0.3 millimeter is, for my application for this material, seems to be. All right, well, that's it for this episode of Savvy CNC. And if you like what you see, please remember to thumbs up, hit like, share it to all your friends. And if you want to see more cool stuff like this, please also check out my Patreon page. I'll put a link right here. And also check out the Facebook page, Facebook.com/Savvy CNC. And again, hey, thank you guys for watching, and